Let's discuss the Earth's atmosphere. It's a wonderful selection of gases that surround our planet and without which we couldn't live here. But what makes up the Earth's atmosphere? What gases make up the atmosphere? Well, we always hear about oxygen because we know we have to have oxygen to breathe, and we hear a lot about carbon dioxide because people talk about the planet warming up and all this. But the truth of it is, the main part of our atmosphere would be nitrogen. Nitrogen. 78% of our atmosphere is nitrogen and 21% is oxygen. 78 nitrogen, 21 oxygen. And the reality is that in this 1% of other gases, that's where we would find carbon dioxide. So carbon dioxide is a tiny, tiny, tiny amount. It's kind of like having a penny out of $1, and the nitrogen would be 78 cents, and the oxygen is 21 cents. But the nitrogen takes up most of the atmosphere, but it's just kind of filler. It doesn't help us. It doesn't hurt us. Now, plants use a lot of nitrogen. Okay, so oxygen is what we need. As we say, 21% of the atmosphere is oxygen. The Earth's atmosphere is a marvelous protective layer. Air has mass. On Earth, mass and weight are about the same thing. We can actually weigh air. Air is like water. The deeper you go, the greater the pressure. Since we live at the bottom of the atmospheric pressure is greatest down here where we live. As we go higher, the air pressure becomes less and less until we can no longer breathe. As we go higher, other things besides the pressure change, so the atmosphere is divided into layers. So check out this balloon. These two balloons were the same size. The red one was filled with air, the blue one was left empty. As we can see, the red one is actually heavier than the blue one, and the difference is the amount of air. Air has mass, therefore air has weight. And also in the red balloon, the air is being squeezed in there, so it's a lot denser. There's a lot more air, the density is greater, so the weight and the pressure is going to be greater. Now about those 5 layers, there are 5 layers of the Earth's atmosphere, and we can see the troposphere, the stratosphere, the mesosphere, the thermosphere, and the exosphere. Now, the important things about each layer is, first of all, the troposphere is where we live. That's where we live. The troposphere touches the Earth. T and T, tropo touches. And as we can see down here in this graphic, the weather happens down here where we live. The weather happens in the troposphere. We know that. Okay? Now, airplanes, the small planes fly down here, but the jetliners that we see sometimes really high, if you see those with the white trails coming up behind them, they're actually flying up at the top of the troposphere into the bottom of the stratosphere. Okay, but the stratosphere is the second layer, SNS, strato for second. That's the second layer of the atmosphere, and it contains what we know as the ozone layer. A little typo there, they didn't spell it correctly. But the ozone layer is very important because it protects us from some of the sun's dangerous radiation. So some of that sun's radiation comes down through, hits the ozone layer and bounces back into space. Okay, now as we go higher and higher, we said earlier, the atmosphere gets thinner and thinner. Okay, there's some things about the temperature, but we're not going to go into those. But the troposphere is where we live. It's where the warmest air is. It's where most of the moisture, it's where most of the atmosphere is. First layer is the troposphere. It touches the Earth. Second layer is the stratosphere. The atmosphere is getting thinner. It's where jet airplanes fly, and it contains the ozone layer, which protects us. The third layer is the mesosphere. The mesosphere, the most significant thing about the mesosphere that I want you to remember is the mesosphere is where the atmosphere is finally starting to get a little bit thicker from space, that is, compared to space. It's finally getting dense enough so that meteors will burn up. So the fact about the mesosphere with an M, is where meteors burn up. Mesosphere and meteors. As we go up higher, we get to the thermosphere. Thermosphere is where the air is, it's actually the edge of space, okay? The space shuttle actually flew in this region right along in here when it was flying. The International Space Station is up in this region also. So the thermosphere is the fourth layer. And finally, the exosphere. The exosphere, I want you to see where EX, I want you to think of the word exit. As you go through the exosphere, you're actually leaving the Earth's atmosphere and heading off into deep space. Okay? So again, we have the troposphere touches the Earth. It's where weather happens. It's where we live. It's where the atmosphere is the densest. The second layer is the stratosphere. Stratosphere contains the ozone layer, which helps protect us from the sun's radiation. The third layer is the mesosphere. Think about the mesosphere is where we see meteors shooting stars as they're burning up. The thermosphere is the fourth layer, and then the exosphere is as we exit into space. So we said that, we live down in the troposphere, and that's where the weather is, and that's where it's the warmest. So that brings us to an interesting question. How does the atmosphere get heated? Well, obviously the sun heats the atmosphere, but the way it heats it might be a little bit surprising. So let's go into that in detail. So if the sun heated the atmosphere directly, since the sun's in space, as that energy from the sun came in, it would heat the atmosphere from the top down. So you would think it'd be much hotter at the top of the atmosphere than down here at the bottom. Well, in the truth, the sun's energy gets here in the form of something called radiation. The sun's energy travels down through the atmosphere. It passes down, and this radiation, when it strikes solid objects, it changes into heat. So the sun's radiation travels down to the earth where it strikes the ground. Think about a car. You get in your car on a hot summer day. The windows have been up and all this, but the seat covers will just cook you. The steering wheel is super hot. Even in a warm winter, on a cold day when it's cold outside in the wintertime, you get in the car and it's warm. That's because the sun's radiation came through the windows and touched the seats and this inside of the car and changed into heat. So radiation, when it touches solid objects, changes into heat or thermal energy. So the ground gets heated up by the radiation. The radiation touches the ground and changes into heat. Now, since the ground is warm, and we've already talked about how air has mass, so air is being pushed down on the ground. So there's air down here touching the ground. And since the ground is warm, the air that touches the ground gets warmed up. So when you touch something and you have direct contact, that's called conduction. Conduction is the transfer of heat through direct contact. We're most familiar with on a hot summer day, if you go outside barefooted and you step on the pavement, or if you're at the beach and you step on the sand, you immediately know how hot it is because the heat goes directly from the sand to your feet and it burns your feet. So conduction is through direct contact. So the cold air is being pushed down. The cold air is touching the ground. Touching the warm ground. As it touches the warm ground, the air begins to get warm. Now, as we know, hot air or warm air rises. So the cold air sinks, touches the ground. Conduction from the hot ground makes the air begin to get warm, and then that air starts to rise. Okay, so conduction actually heats the atmosphere. Now, as that warm air rises, then we have another process called convection. Convection is a transfer of heat through a gas or a liquid. So as these warm air molecules are rising up, they bump into other molecules. As they bump into other molecules, they share some of their heat. So convection is how warm air moves around, the heat energy travels around through the atmosphere. But the air initially gets warmed up by conduction, by touching the warm ground, and the warm ground got heated up by radiation as it traveled through space, touched the ground, and turned into heat. As the air gets higher into the atmosphere, it starts to cool off. As it cools off, it becomes more dense, and so cold air sinks. Cold air sinks because it's denser, it's heavier. So Warm air rises because it's less dense. Cold air sinks because it's more dense. One last thing to remind you of. Since we live down here, this is where the weather is, this is where we live, this is the troposphere, and so this process that we just talked about explains how the troposphere gets warmed up. Okay? Now that we understand how the atmosphere gets heated, hopefully this will help us to better understand something else we've already discussed and studied, the water cycle. So think about it. The sun's radiation travels down to the earth. The radiation touches the ground and it touches the water. We know as it touches the water, it's going to cause these water molecules to get warmer and they're going to evaporate, changing into a gas. Now, the warm air, because air is also being warmed up down here by the radiation, this warm air, as it rises, it carries the water vapor up with it. So the radiation heats the ground and heats the water. The heat causes evaporation and it causes the air to get warm. The warm air rises, carrying the moisture up with it. The higher we go, the cooler it gets. So as the water vapor gets higher and higher into the sky, it begins to condense. It cools off and condenses. Remember, condensing, cooling causes condensation. All right. As it gets condenses enough, as the water particles get bigger and bigger, then they turn into precipitation and fall back to the earth. So the water cycle is driven by this whole same process that heats up and cools off the atmosphere.